Live from Earth. It's Space Radio. I'm Paul Sutter, astrophysicist at Stony Brook University and the Flatiron Institute. And for the next half hour, your agent to the stars. We've got an exciting show for you today where we are talking about the UFO report. I got to do it. I got to talk about it because it's the thing and everyone else is talking about it. So I got to talk about it. So we're going to talk about it and we're going to have a great time. I promise. This show lives on listener questions. That means you. I'm looking at you. It's your questions. We record every Thursday at 8 p.m. Eastern here in Spaceman Studios in New York City. So leave a voicemail to get yourself on the air. You can also follow along with our space cadets tuning in live from around the world. Got a great audience tonight from Bristol, Indiana, Watford, Long Beach, California, San Juan, Puerto Rico, Kosovo, Westminster, Maryland, Pell City, Alabama, Idaho Falls, London, UK, Carbondale, Illinois, Columbus, Ohio, Washington, D.C., Howell, New Jersey, Ballack, France, and more. Thank you so much for joining. Now, if you want to get in on that Space Cadet action, and I know you do, go to spaceradioshow.com. Thank you, Russell, for the Super Chat flying on in. That's right. You can support this show through Super Chats, and it's great, and everyone loves it. Thank you, Russell. Hello from Norway, checking in at the last minute. Greetings from Antarctica. I do not believe you. There's like 40 people in Antarctica right now because it's winter there. And so unless you're one of those weirdo overwinter people, I'm not buying it. I'm not buying it. But if you are really from Antarctica, hello and welcome to the show. Corey S. tuning in from British Columbia. Guys, so everyone's heard of the UFO. Oh, yeah, it's been a while. Hasn't it? It's been a few weeks since our last show. Vancouver, Canada. I miss you checking in from the Mariana Trench. If someone says Mount Everest, it's not. No, it's... Yeah, you can see new digs, new Spaceman Studios. We moved. That was pretty intense. Denmark turned to... Now you're just naming places. You have to be from the place. You have to be currently located there. You can't just throw a pin on a map and say you're like, hello from Fiji. No, you can't do that. Zimbabwe, checking in. No, you're not allowed. Middle of the Pacific. It's not allowed. Yeah, new digs, new Spaceman Studios, new office, new deal. The move is nearly complete. What you don't see off camera, by the way, is the pile of boxes that we stashed in the office and a bunch of pictures that we haven't put up on the walls yet. It's, moving is fun. Now, the UFO report, or should I say the UAP report? I don't know why the military even bothered trying to rename UFOs to UAPs. UAP stands for Unidentified Aerial Phenomena, because the whole UFO thing is now associated with aliens from another solar system. So, like, by calling it UAPs, like, we're fine now. I don't know. It's there. I don't know. Russell, I know. Question mark, chalkboard. The chalkboard is no longer with us. You know, I've had that chalkboard. I've moved. This is like my fourth move in 2 years. It's been a crazy few years. In every move, I've painted a wall, chalkboard black, done the thing. And this, as I'm looking around the new Spaceman Studios, the new setup, I remember when we toured this home and checked it out, it was just time to move on from the chalkboard. It was just time to move on. But enough about me and more about UFOs. So the UFO report is lame. That's my verdict. I knew it was going to be lame. I called it. I did a little social media video for Discovery Channel. And I said, it's going to be lame. I remember the producers were like, well, Paul, can you be a little bit more excited about it? Like a little bit more. I said, it's going to be lame. The thing finally came out. It's 9 pages long. The only reason we have it was ordered as a part of the stimulus package last December, just to show you like how weird stimulus packages and omnibus bills can get. Like it included, I just hit my knee on my new desk. I'm getting used to the ergonomics of this whole situation. They're like, okay, we also want to report on UAPs. There's all these sightings that are making Congress twitchy, and they're like, what's going on in our restricted airspace? The answer, at least the unclassified answer, is we don't know. There's limited, and here's some quotes: limited data and inconsistent reporting are key challenges to evaluating UAP. Like, it's just a bunch of noise and junk. Some observations could there be the result of sensor errors. There is a safety of flight issue. We don't know what it is. It could be technologies like drone technologies. Yeah. They were, of the 144 sightings, they were able to identify one UAP with high comments, which turned it from an unidentified aerial phenomenon to an identified aerial phenomenon, an IAP. The IAP was a large deflating balloon. That's what we got. That's all we got. This is it. This is it. That's it. Now there's more that is classified, and then there's even more that they're not even putting in the report, because guess what? Militaries around the world love to keep secrets, even when they say they aren't keeping secrets. There's just nothing. It's boring. Like, it's a UFO report. There's a bunch of stuff in the sky that we don't understand. Is it aliens? Yes, it could be aliens. I have to say that because I'm a scientist. I have to admit all possibilities. But that's like not even at the bottom of the list. That you can imagine the list of things it could be. And then go reach the bottom and then keep going. And then like way down past the bottom, almost so far at the bottom that wraps around it being at the top again, but still at the bottom is aliens, because aliens aren't visiting us. It's a bunch of weird stuff in the sky. I don't know what it is. It's unidentified. But just because you don't know what something is, it doesn't give you permission to claim to know what it is. That is not how evidence works. That's not how science works. So all the people saying, well, it's aliens, you don't know. If you don't know, you don't know. That's as much as you're allowed to say. I see in the comments, I'm sure Avi Loeb, arch enemy of the show, by the way, it has been doing. Yeah, the UA could have been alien devices transmitting to Oumuamua. Yeah, I wonder why he lost that. He's no longer the chair of the astronomy department at Harvard. I wonder. Let's do some questions, guys. Folks, put some questions into the chat. I've got some voicemails I want to read. I want to have a good time. I want to relax. I did the thing on the UFO report. It's lame and it's done. Some people will be interested in it, but I'm not. We got a question here from Russell as part of the super chat. Thank you again, Russell, for that. Can we use the infrared electromagnetic heat of the cosmos as a backdrop to spot those transmitting massive cold comets passing in front of us? So there are a few different backgrounds to the universe. The most famous background is the cosmic microwave background. This is radiation emitted when our universe was like 380,000 years old. Totally saturates the universe. It is the number one source of light. By total number of photons, it's like 99.99999% of all photons in the entire universe. If you could put on microwave goggles and take away the sun, you would see the cosmic microwave background. There are other backgrounds. There is a visible light background that's just like the general noise from all the galaxies glowing out there. There is an infrared background from all the hot objects out there. We actually have a very tough time characterizing the infrared background, and that's because so many things in our nearby galaxy, within our own galaxy, are hot in the infrared, like the sun, like the planets, like every single star, like grains of dust. They're all emitting an infrared. And so it's hard to separate what's coming from our own galaxy versus what's coming from the background. When it comes to the microwave background, we are able to do some very interesting things like spot clusters, because clusters absorb the light from the microwave background, and because their hot gas actually make a little hot spot on the microwave background, so we can spot clusters of galaxies. That's pretty cool. As far as using the infrared background to spot nearby objects, we just don't have a good enough understanding of the cosmic infrared background. We don't characterize it enough. We don't map it often enough in order to see colder objects in front of it. So I'm not going to see that. I'm not going to see that as a very useful tool going forward. Good idea, though. Points for trying. I really like that idea. Moving on. Matthew Fleury on YouTube. Hot take. Is time emergent or fundamental? Man, I wish I understood time, because then I would have a Nobel Prize and we'd already be at the cheese segment by now. But we got to do some science. We got to do our homework before we get our reward. What is time? I don't know. I was actually doing an interview for a podcast this morning, and the question came up about the nature of time and my work with artists, Siren Modern Dance in New York City, on TikTok, exploring the nature of time through all these different lenses. Yes, science has some things to say about time. We know you can skip forward into the future if you travel fast enough. It appears that you can't travel back in time. That's pretty much all we got. It's a pretty short list of things that science has to say about time. What else? I mean, I don't know. Is it fundamental? Is it emergent? Is it due to some weird interaction? But anything you ask about time, anything you say about time, you have to say about space. Because time and space are linked. They're intertwined. They're interwoven. Yes, time is special in the sense that you can only move forward. You can't move back. But if you want to say, well, time is emergent, it's like it's really caused by something else, and it's like this side effect of some other physics, then you have to say the same thing about space. And like no one asks that about space. Well, I guess some people do, but like mostly no one does. If you want to develop something weird about time, you also have to talk about space, because we live in a 4-dimensional space-time universe. Tom P, is the microwave background supposed to represent the entire universe? The cosmic microwave background, what it is, it's so hard to describe and visualize in 3 dimensions, but imagine you're sitting inside of a balloon. No, scratch that. We're going to go with a different thing. I'll get to the balloon here in a second. Our whole universe transformed. So every part of the universe emitted cosmic microwave background, CMB stuff. Every part of our universe glowed when our universe was 380,000 years old. We all did. So the patch of universe that you are sitting in right now, at this very moment, billions of years ago, emitted some cosmic microwave background. What we see as our cosmic microwave background is if we were on the inside of a balloon and we're seeing the light as a shell, as a sphere surrounding us. We're seeing that skin of the balloon from the inside out. That is the light that was emitted from that patch of the universe over there that is just now reaching us today. So there was a patch. We emitted our part of the cosmic microwave background. Now that light is somewhere far, far away. And then there's some distant patch that emitted some light, and that light is now reaching our eyeballs and our radio telescopes. And so we see it as a shell surrounding us, because that is the part of the universe that emitted the microwave background that is just now reaching it by the time we turn on our detectors. So it's not supposed to represent the entire universe. It represents that part of the universe that emitted that we are now catching. If we were to wait another million years, we would see another part of the universe illuminated with cosmic microwave background. How far away is the cosmic microwave background? The cosmic microwave background is very, very near to the edge of the observable universe. Remember, it was emitted just when our universe was 380,000 years old. So it's about 380,000 light years shy of the edge of the observable universe, which is about 45 billion light years away. Paul, what's your take on the likelihood of life being in other galaxies like exoplanets? Yeah. This is the heart of the question. So skipping all this UFO, UAP stuff, and potentially even skipping all this SETI stuff. I'm recording a podcast episode about SETI, probably this week. It'll be out in a couple months. The big question that's motivating us, and it's a question that we've been asking for millennia, is, are we alone? When we look out at those multitude of stars and know that there are even more stars behind that, and now we know that there are worlds attached to those stars, are we alone? Science has been trying to tackle this question for like 50 to 70 years, depending on how you count, looking for signs of intelligent life. We haven't found squat. Looking for signs of any kind of life, haven't found squat. Looking for signs of life in our solar system, haven't found squat. We haven't found any signs of life anywhere. And this is a little worrying. It's a little worrying because we like to assume that we're not special. We like to assume that what we experience here on the earth isn't really out of the ordinary. Like, there's a whole bunch of earth, there's a whole bunch of suns, there's a whole bunch of water. So if life happened here, the underlying assumption is that life pretty much happens anywhere it can. But we estimate there's like 5 million Earth-like planets with sun-like stars in the galaxy, in the Milky Way galaxy alone. So does that mean there are 5 million intelligent species out there? Well, as far as we can tell, we're absolutely alone. Now, it could be that our galaxy is filled with millions of intelligent species, but because of the enormous time and space different distances, we're just never going to see them or hear from them. We'll never see a sign of their technology. Maybe, I don't know. I'd like to think that there's life out there. I just like to be an optimist. This is not based on evidence. This is just based on my gut intuition that with the hundreds of billions of stars in the Milky Way, the hundreds of billions, potentially trillions of galaxies in the observable universe, plus the unobservable universe, are we alone? It seems weird for us to be alone, honestly. But then again, nature has been weird before. So maybe we're it. I don't know. It makes me uncomfortable to think that we're alone. It makes me uncomfortable. Maybe it's just because I'm a geek and I like to read a bunch of science fiction stories. Zero Skull is asking, what's your favorite cosmic object and why? Of course, I'm going to say, of course, my favorite object is the object, the largest pattern found in nature, the large-scale structure of the universe, the cosmic web. This is the thing made of galaxies. In the same way your body is made of cells, if your cells were 1,000,000 times smaller, it is the largest pattern found in nature. It is a structure that has been evolving for billions of years. It is a structure that is currently being ripped apart by dark energy. It will not last long. It will only last a few billion more years before it completely evaporates. It's my thing, and I studied it. It was a part of one of my main research lines. I'm still connected to a bunch of Void researchers, participate in some collaborations, and I have a really good time thinking about the cosmic web, large-scale structure. The big empty patches, the cosmic voids were my specialty. I was an expert on nothing. I am an expert on nothing. That's pretty fun. Arnetta, I'm just doing a whole bunch of questions today. Like, let's just do it, because it's been so long. What are boson stars? Boson stars. Boson stars. You gotta love these random jargon terms that just get tossed around. Okay. Just about everything you touch. And by just about, I mean all the things that you touch are made of a kind of particle called fermions. So, electrons, protons, neutrons, muons, all the ons. They're fermions. Okay, it's just a kind of particle. Don't worry about it. There's another kind of particle called a boson. There are two kinds of particles, fermions and bosons. Fermions are the building blocks. They're the things that make up the stuff. You hold a book in your hand, guess what? It's made of a whole bunch of fermions. The bosons are the force carriers. So like the photon is the force carrier of its light. It's the electromagnetic force carrier. It's a boson. You got the gluons for the strong force, bosons. You got the W and Z bosons. Guess what? It's in the name. They're bosons. Our universe, according to the standard model, is divided into these two things. We got the fermions and the bosons. You got the building blocks and the force carriers. But then we run into dark matter, and dark matter is super weird, and we don't understand dark matter, and we wish we did. And dark matter doesn't necessarily have to play by the standard model rules because it's by definition outside of the standard model of particle physics. It's new physics. And so it could be, one idea that's out there is that dark matter is a different kind of boson. that dark matter could be a kind of particle that is still a boson, but can still build stuff. An example of this would be an axion. An axion is a hypothetical particle that is a boson, but can still build stuff. So it smells like a force carrier, but it acts like a building block. And so the hypothesis goes that if their dark matter is built out of these bosons or axions or other exotic particles, maybe you can get dense enough agglomerations that there be like dense balls of them, which when they're dense balls of something in the universe, astronomers call them stars. They're not glowing, they're not heating, they're not lighting up. They're just big balls of bosons. That's what they are. I do want to remind everyone that this show is brought to you by you. That's right, you. Go to patreon.com/PMSutter to learn how you can keep this show going. That's patreon.com/PMSutter. You can also drop a super chat into the chat if you're watching live anytime. CDP, a personal one. What led you to study physics? I applied. I don't know, like I actually started my undergraduate career in computer science because I'm a big computer geek. Wanted to be a computer programmer, but I don't know, it just wasn't lighting my fire. It just wasn't getting very exciting for me. 3 years in, I took an elective in astronomy, and I was reminded, growing up, I was reading all sorts of books on astronomy and physics. Always assumed it was for someone else, someone smarter than me. Fell in love with the subject again in college. Week later, switched my majors to physics. Had no idea what I was going to do with that. Ended up going into grad school in physics and doing the whole thing. And then doing pure research, doing a postdoc. And then over the past few years, I've transitioned to doing more outreach communication, having fun, talking about science, exploring the nature of our universe and sharing that with audiences. And I'm having a blast. Whoo, boy. From Swed Miro. Apparently, when a white dwarf cools off and stops emitting light, it will be called a black dwarf. Will you join the movement to call it a much cooler dark star instead? I'll sign that petition. Dark stars. When white dwarfs cool off, they should be called dark stars. Although, isn't dark stars potentially taken by hypothetical dark matter stars in the early universe? They may have taken the name dark star already, because the people who were looking at white dwarfs, they said, oh, when they cool off, they're not going to glow. So let's call them brown dwarfs. Oh, no, shoot, brown dwarfs is already taken, so we'll call them black dwarfs. But then in the meantime, people researching dark matter coined the term dark star. And so now I think it's taken. So it's going to be a multi-layered petition. So we're going to have to eliminate the term dark star. We're going to have to call them dark matter stars. So we can free up the term dark star to apply it to a cooled off white dwarf. And then black dwarf is up for grabs. It's up for grabs. Maybe now, instead of boson star, we can call them black dwarfs. So here's my proposal, my 4-point proposal as I run for president. 3 points, I lost count. Number 1, dark star is going to be renamed dark matter star. Number 2, black dwarf is going to be renamed dark star. Number 3, boson star is going to be renamed black dwarf. Boson star, we're just throwing in the trash. We don't need it, and it sounds lame, so it's gone. All those in favor, say aye. Richard Petch, any thoughts on the Hubble situation? The Hubble has been on life support for like 20 years. The Hubble was supposed to be replaced over a decade ago, and it wasn't because the James Webb is delayed. And it looks like the James Webb is going to be delayed again because the rockets are getting a little vibrational, which is a bad thing for sensitive electronics and telescopes. So we don't know what's going on. And we've got lots of eyes going on. I think the eyes have it. I think the motion passes. We're going to do a little name shuffle. And Black Dwarf we decided is going to be Boson Star. Boson Star is out. It's out. So I don't know. Like, I wish the Hubble well. We've gotten more out of that machine. We've gotten more out of that machine than we could have ever asked for. There is more data. People don't really realize this. There is more data collected by these major observatories and particle experiments than can ever be examined in a generation of scientists. There is more observations collected in the Hubble archives than the entire generation of astronomers could possibly process. There will be generation after, like 60 years from now, people will go back in the Hubble archives to do fresh science. The particle accelerators like Fermilab and LHC and CERN and all that, they collect so much data that you could set 100 graduate students on that one data set. They could all write original research papers generating new information. And there's still data left over to be processed and analyzed and studied and understood. It is just the nature of it. Like, the Hubble is great. We have so much science from the Hubble. If it is the end of the line for the Hubble, we'll do a special episode on that. But if it's not, it's not. And look what they did with Kepler, that amazing exoplanet hunting telescope. Like, it died like 5 times, 3 times, twice, I don't know. And they kept going with like zombie Kepler mode, like, so they could still do surveys. And it was fantastic. Richard says, I honestly find it fantastic how long these machines last and how they encapsulate the public's attention. It's pretty heartwarming. Hubble has been a fixture of like my life, right? I was a kid when the Hubble went up, and I'm not so much a kid anymore. And the Hubble has just been there. It's been a part of my life. And yeah, everyone knows the Hubble. Let's eat some cheese. Let's drop a slice in honor of the Hubble. I hope it's not the end of the Hubble. That'd be great. Today's cheese is very exciting. Ooh, stinkier than I expected. It's called Finback. Finback, and it's a local New England cheese. It's from Mystic, Connecticut. Apparently, Andreas, the guy at Dom's Cheese Shop, he told me, and the cheese is brought to us by Dom's Cheese, DOMScheese.com. It's a slow mill cheese, complex notes of cooked milk and brown butter. Because apparently the guy who does this, who does this Finback cheese, is like, he went to Europe to figure out how to make cheese, because that's what you do. And then there are people making cheese in Europe who are like, yeah, this is the recipe we've been doing for 400 years. This is the way you do it. So he like learned the basics, and he's like, well, I can do whatever I want, because I'm not in Europe anymore. I'm in Mystic, Connecticut. And look at that lovely, lovely color and texture. Wow. This is going to be fun. Good old Mystic, Connecticut. Legendary town. Very crumbly. This is far crumblier than I thought. It is a cow's milk cheese. Very crumbly, lovely texture. Let's see. Dom's cheese. Thank you. It's a much looser texture than I was expecting. I was expecting it to be creamy, but it's falling apart as I eat it. Very crumbly, but in a very lovely way. I definitely get those notes. There's this deep note, and usually when cheeses go deep, it goes woodsy or like funky. Like, I'm a bacteria and now I'm on your tongue. This is going deep, like you're going to think about me. You're going to think about me. Because on the surface, the first bite, you're like, oh, it's a simple cheese, very similar to cheddar. But then you keep going and it's like, no, I'm not cheddar. Anyway, I could just keep eating that. And I will. Guys, this show goes so fast. Hope you like the new digs. Hope you like the new Spaceman Studios. I should be on next week. Nancy, am I on next week? Are we doing a show next week? Or have I told you I can't do one next week? Summer schedule, it's going to be rough. Oh, yeah, I think we have a guest next week. Very exciting. Come in next week. We'll keep this chat going. We're going to have a great time. Once again, you can keep this show going by going to patreon.com/PMSutter. That's patreon.com/PMSUTTER. I'm Paul Sutter. This show is brought to you by you. Thank you, Nancy Graziano, for wrangling the Space Cadets. Catch the live stream every Thursday, 8 p.m. Eastern, spaceradioshow.com for all the links. And of course, thank you again, Space Cadets, for listening. See you next week. And remember, science is for sharing. End of transmission.